One of the best uses of factoring is to help us more easily solve equations where we have a squared and it's set equal to 0. Unless you want to use the quadratic formula, which is always okay if you remember it, but sometimes factoring gets us to answers much more quickly and more easily, especially if you don't have a calculator handy. So looking at this one, yeah, I can't factor out a 4 because 4 doesn't go into both terms, but the number 121 should set off a little alarm in your head, as well as the number 4. If you look, both of those terms are perfect squares. If you recall, you can easily factor the difference of two squares. The square root of 4x squared is 2x. The square root of 121 is 11. And then you just go plus, minus. Still set equal to 0. Now, one of the fun math facts about 0 is if this quantity evaluates to 0, then it doesn't matter what this evaluates to, because 0 times anything is 0. So if I could come up with some magic number that made the whole first half equal to 0, that would make everything equal to 0. In other words, if I could make the value 2x plus 11 excuse me, equal to 0, the whole thing would be 0. Likewise, if I could make the second term, 2x minus 11, equal to 0, that also would give me 0 overall. Either one, since it's something times another thing, if either half is 0, then the whole thing's 0. On the left, the way I would solve that is by subtracting 11. Thus 2x would equal negative 11. Dividing by 2, x equals negative 11 halves. On the right, I would start by adding 11 to both sides. 2x equals 11. Dividing by 2, x equals 11 halves. So we have two answers, negative 11 halves or 11 halves, which sometimes you might see written as x equals plus or minus 11 halves. Not too bad, huh? What if we had something along the lines of, say, x squared plus 7x plus 12 equals 0. Well, this is not the difference of two squares. It's not a square number at the end. There's nothing to factor out, so I just got to do some good old-fashioned factoring. Alright, now I need an x and an x. Two numbers that multiply to 12 and add up to 7 has to be 3 and 4. So I know I would have an answer if x plus 3 was equal to 0, or if x plus 4 is equal to 0. On this side, I've subtract 3 from both sides. X equals negative 3. This one, subtract 4 from both sides. X equals negative 4. So our answers are x equals negative 3 and x equals negative 4. They're both answers. That's how you solve quadratics.